Hello friends, good evening to everyone. Welcome to my channel Belagali's class. Belagali's class. Friends, done in the previous video or class, the property number 7, which is on even and odd functions. That property or theorem is done. Related examples done, my friends. Now in this video, in this class, I am going to do few more examples, lengthy examples, my friends. If it all comes, they give these examples under 6 marks instead of theorem with the example. If any examiner wanted to change, directly he will give these examples under 6 marks direct, my friends. Okay? Yes. Still there is one more example they may give along with a theorem. Theorem I have written here. Prove a definite integral 0 to a f x dx equal to 0 to a f of a minus x dx, and hence evaluate this. And hence evaluate integral 0 to 1 tan inverse 2x minus 1 upon 1 plus x minus x square. Above is a theorem and evaluate this example integral. Yes, my friends, as usual this theorem is there. While doing this example, I use this property of inverse trigonometric functions. It is a property done under inverse trigonometric functions, which is tan inverse x minus y upon 1 plus xy equal to tan inverse x minus tan inverse y. We have done, my friends, many examples based on this. Even in ITF, even other than ITF also, even differentiation everywhere. This should be one first, and there must be opposite signs, minus plus, and the second term should be product of these two. First term is x, second term is y. What is the product xy? So my friends, 1 opposite signs, it should be the product of these two. If it is so, you can write what? Tan inverse of the first minus tan inverse of the second. This right there. This I use while doing this first example, my friends. This above they give theorem here, that property with example, hence evaluate this. My friend, it is integral 0 to 1 tan inverse. This 2x is adjusted like this. X minus of minus x. Minus of minus x is plus x is 2x. This is minus 1 minus 1. So my friend, this 2x minus 1 is written as x minus 1 minus x. Down, denominator 1 plus x is common. X into, if you take x common, it remains 1 minus x. See my friend, this is 1. Opposite signs. This is the product of these two terms, x into 1 minus x product. If it is so, we can apply that result. It is tan inverse of the first term minus tan inverse of the second term dx. I write individual integrals, my friend. Tan inverse of the first integral minus tan inverse of the second integral. I apply that theorem. Replace your x by upper limit minus x because the lower limit is 0. Replace your x, replace this x by upper limit minus x, 1 minus x. Yes, my friend. What is this? 1 minus x. You keep it as it is, 0 to 1 tan inverse 1 minus. So it is 0 to 1 tan inverse 1 minus x minus 0 to 1 tan inverse 1 minus x. Cancellation plus with minus give 0. Therefore, the value of this definite integral is 0, my friends. It is a simple example. They ask along with a what? Theorem, that theorem, my friend. Next example. See. Prove definite integral 0 to pi x upon 1 plus sin x dx is pi. Prove this. Yes, my friend, that is why no, hence evaluate no. It is prove means independent example. These examples, if the examiner wanted, they may give under 6 marks. Otherwise, these are lengthy examples with the theorem. Yes, anyway, it all depends upon the examiners, my friends. Prove integral 0 to pi x upon 1 plus sin x dx is pi. Let I equal to this integral. Apply the theorem. Lower limit is 0. Therefore, replace x by upper limit minus x, pi minus x in 1. I equal to integral 0 to pi, replace x by pi minus x, replace x by pi minus x. That numerator as it is, my friend. 180 means no change, sign remains, sign of the angle is x. Second quadrant, sign is positive. So, it is pi minus x upon 1 plus sin x, making use of allied angle formula, my friends. Write two separate integrals. Integral pi upon 1 plus sin x, this minus integral x upon 1 plus sin x, this. Then starts the evaluation of this integral. This pi is out. Integral, it is 1 upon 1 plus sin x. Multiply numerator denominator by changing this sign. If it is 1 plus sin x, change to 1 minus sin x and multiply both numerator denominator. If it is minus here, you have to multiply with 1 plus sin x. Minus, what is this, tell my friend? It is 0 to pi x upon 1 plus sin x. 0 to pi x upon 1 plus sin x is I. This is I. So the value of this integral, we have taken it as I have substituted this as I. Then you take this minus I this side, plus I. Already one I is there. I plus that minus I becomes plus I. This pi, 1 into 1 minus sin x. 1 plus sin x into 1 minus sin x. A plus b into a minus b is a square minus b square. 1 minus sin square x is cos square x. 1 minus sin square x is cos square x here, my friend. Numerator is same. 1 minus sin x upon cos square x. Cos square x. This 2 I have taken this side. It is pi by 2 into integral 0 to pi 1 upon cos square x minus this cos square. Split it cos x into cos x. Written 1 by cos x into sin x upon cos x, which is nothing but 1 into sin x is this, cos x into cos x is cos square x. Friends, identity, sec square x minus 1 by cos sec x, sin by cos is tan x dx. Integral of sec square is tan minus integral sec x into tan x is sec x, 0 to pi. Yes, my friends. Put x equal to upper limit, pi by 2 into tan pi minus sec pi upper minus, put x equal to lower, x is 0, tan 0 minus sec 0, tan pi 0 minus sec pi minus 1 minus tan 0 0 minus sec 0 1. This is pi by 2 into, it is 0 minus of minus is plus 1. Minus of minus is plus 1. 1 plus 1 is 2. 2 cancels with 2, giving pi. Therefore, integral 0 to pi, x upon 1 plus sin x dx, with the RHS is pi, is pi. Therefore, this is the definite integral. My friends, copy it. Yes, friends, copy it. Yes, friends, now you copy the second example. I will rub this. Yes, friend. This is second. Next is third example. Third example, 2 integral 0 to pi sec x upon, this is x sec x down is sec x plus tan x dx equal to pi. Prove definite integral 0 to pi x sec x upon sec x plus tan x is pi. Yes, friends, let I equal to integral 0 to pi x sec x upon sec x plus tan x dx. This is I. Then replace your x by pi minus x. Pi minus x in 1. Where is 1? This is 1, my friend. Yes, you get I equal to integral 0 to pi. X you are replacing by pi minus x. Then sec x you are replacing by pi minus x. Denominator sec replacing by pi minus x plus tan x replacing by pi minus x dx equal to integral 0 to pi, and this is pi minus x. Tell my friend, pi means sec remains sec x. In the second quadrant, sec is negative. Denominator same, sec is negative. Second quadrant, tan is negative. It is minus tan x dx. My friend, this minus with a down minus becomes plus. Yes, it is integral 0 to pi minus x. I take this minus here, this minus I write here. It is sec x. I take minus outside. It is sec x plus tan x dx. My friends, above minus with down minus gives plus. Therefore, it is definite integral 0 to pi sec x minus x sec x denominator is sec x minus tan x. Yes, my friend, I hope all the steps are clear. See, this is the definite integral. We have to evaluate this. Yes, let I replace pi minus x into sec pi minus x upon sec pi minus x into tan pi minus x. Sec of 180, no change, sec. Second quadrant, sec is negative. Second quadrant, tan is negative. Minus, this minus is taken out. Minus upon minus is plus. pi sec x minus x sec x upon denominator. Then you write two integrals, pi definite integral sec upon sec x minus tan x minus integral x sec x upon this. Write two definite integrals. Yes, friend. Now this theorem part I keep it. We are using it upper limit minus x. Next I write two separate integrals I equal to that pi I take outside integral 0 to pi sec x upon sec x minus tan x, no, plus tan x dx. This, my friends, this pi is taken out. Integral sec x upon sec x minus tan x minus integral x sec x. This is minus integral 0 to pi x sec x upon sec x minus tan x. No, here if you take minus outside it becomes plus. This is plus sec x plus tan x dx, my friends. This minus x sec x upon sec x plus tan x sec x upon sec x plus tan x by 1 is nothing but I. You can put that integral equal to I. Then you evaluate this equal to, my friend, this is pi. Definite integral 0 to pi, it is sec x upon this equal to pi into definite integral 0 to pi sec x upon sec x plus tan x into multiply both numerator and denominator by sec x minus tan x, denominator sec x minus tan x dx. This, my friend, minus this is integral I. This integral is I substituted. Yes, friend. This side you have already I, LHS I. That RHS minus I becomes plus I equal to pi into definite integral 0 to pi. What is this? Sec x into sec x minus tan x. This is numerator. Denominator is a plus b, a minus b, a square minus b square. My friend, it is 2i pi. Integral 0 to pi. Simplified. Sec into sec is sec square x minus sec x into tan x. Denominator is 1 pi. You know this, my friend. You know this. What is it? 1 plus tan square is sec square. 1 plus tan square x is sec square x. Therefore, 1 equal to sec square minus tan square. sec square minus tan square x. So we are substituting for what? Sec square minus tan square is 1. This is 1. Yes, I equal to, my friend, this is pi by 2. Write the integral. Integral of sec square is tan x minus integral of sec into tan is sec x. This is lower limit, this is upper limit. Yes, my friend. Put x equal to upper limit. Put x equal to upper limit tan pi minus sec pi. This is upper minus lower. Put x equal to 0. Tan 0 sec 0. Yes, friend, this is pi by 2. Tan pi 0 minus sec pi is minus 1. This is upper. Tan pi 0 minus sec pi is minus 1 minus, friend, tan 0 is 0 minus sec 0 is 1, which is pi by 2 into it is minus of minus, both minus of minus. So it is pi by 2 into 2, which is, my friend, it is pi itself. Therefore, I equal to pi. I is pi. But what is I? What is I? Definite integral 0 to pi. This is I, my friend. X sec x upon sec x plus tan x is pi. So this is x sec x. Sec x plus tan x. Dx. Its definite integral is pi. Therefore, it is RHS. RHS. Lengthy math, these independently they give for 5 or 6 marks questions. 6 marks questions. Yes, friend, copy it. Yes, friends, I hope it is clear. It is clear. Yes, my friends. I will explain once again. Prove this equal to pi. Let I equal to this integral. Replace x by upper limit minus x, that property of definite integral in 1. X is pi minus x. X is pi minus x. Yes, my friend. In case of sec and tan, pi means no change. Sec is sec, tan is tan. But angle is in the second quadrant, my friends. Second quadrant, what is this? 0. This is pi. Pi minus means angle is in the second quadrant. Second quadrant means this is all silver teacups. Sin is positive, cos is negative, tan is negative. Minus is common here, this minus I have written here. Minus upon minus is plus. Simplify. Phi sec minus x sec upon the denominator. Two integrals. Phi constant out. Sec x upon sec plus tan minus x sec x upon sec x plus tan. I have written, my friends, two integrals. This is one, this is second. This evaluation, to evaluate this integral, multiply both numerator and denominator, changing the sign. Sec x minus tan x multiply. But what is this, my friend? Integral I. This side is your LHS is I. Bring this side. I plus I. Pi into sec x into sec x minus tan x upon sec x plus tan into sec x minus tan. A plus b into a minus b is a square minus b square. 2i equal to pi into 0 to pi. What is it? Sec into sec is x square minus sec x into tan x upon 1. Evaluate it. I equal to pi by 2. Integral of sec square is tan minus integral of sec into tan is sec x. Lower, upper. Put x equal to upper pi. Put x equal to lower 0. Tan pi is 0. Sec pi is minus 1. Minus tan 0 is 0. Sec 0 is 1. Now my friend, minus with minus is plus 1. Minus with this minus is plus 1. 1 plus 1 is 2. 2 cancels pi. Therefore, the given integral is pi. This is the solution of this definite integral, my friends. Next example. Yes. Prove integral 0 to pi. It is x upon a square cos square x plus b square sin square x dx equal to pi square upon pi into pi upon 2ab. This we want to prove, my friends. First, let I equal to the given integral. Let I equal to the given integral 0 to pi x upon a square cos square plus b square sin square dx. Let I equal to this. Next, same. Replace your x by upper limit minus x because lower limit is 0. Replace x by pi minus x in this integral. Therefore, I is integral 0 to pi. Yes, friend. X replaced by pi minus x. Denominator a square cos square pi minus x plus b square sin square pi minus x. Yes, my friend, dx. You have to put the values. Pi means no change, cos x. Second quadrant minus cos x, square is there, plus. Sin in the second quadrant is positive, it is plus itself. About the denominator, integral 0 to pi, it is pi minus x upon a square into, it is what? Minus cos x, pi. Pi, cos remains cos. Second quadrant minus, but square is there. Because of the square, it becomes what? Again plus cos square x, plus cos square x. So it is a square cos square x plus b square. Sine, it is what? Positive in the second quadrant. Square is also there. It is positive dx. Now you write two integrals, my friends. Two integrals. One integral is with pi. This is integral 0 to pi upon a square cos square x plus b square sin square x dx minus I write down integral 0 to pi it is x upon this x, denominator is same, otherwise I write that side, my friend. This is minus integral 0 to pi, this is x upon a square cos square plus b square sin square. Yes, friend, this is minus x upon a square cos square plus b square sin square. This dx is there. Yes, my friend. This, if I replace upper limit minus x, then it is 2 times 0 to pi by 2. It is 2 times integral 0 to pi by 2 pi upon this is a square cos square plus b square sin square dx. What is this? This is I. X upon a square cos square plus b square sin square. We have taken this as I. Then, because of what? Here, because cos pi minus x is same in this case what? F of because f of this theorem 2a minus x means f of pi minus x is plus fx. If it is plus fx, then this is what? 2 times 0 to pi by 2. My friend, this theorem, this is because of this integral 0 to 2a fx dx equal to 2 times integral 0 to a fx dx if f of 2a minus x equal to plus fx. It is plus fx. Sixth property, my friends, sixth property. If you replace x by upper limit, this pi minus x, you get this is plus means it is fx itself, same. Therefore, this 0 to pi can be written as 2 times 0 to pi by 2 because of this reason or because of this theorem. Yes, friends. Right, continue with it. Yes. This minus I, we are shifting that side. Therefore, I plus I. This is I plus I equal to 2 times integral 0 to pi by 2. This pi is also taken out. You divide both numerator and denominator by cos square x. Divide both numerator and denominator by cos square x. This equal to I plus I equal to, this pi is also taken out. It is 2 pi integral 0 to pi by divide both numerator and denominator by cos square x. Divide both numerator and denominator by cos square x. 1 upon cos square x. Denominator a square plus pi. Cos square upon cos square is 1. B square into sin square upon cos square. This is b square into cos square x upon sin square x dx. Yes, my friend. Yes. Simplify it. 2I equal to 2 pi integral 0 to pi. It is sec square x. Denominator a square plus b square. Sin square upon cos square is tan square x. My friends, sin square upon cos square is tan square x. Here, my friend, this is sin square x. B square into sin square x, you are dividing by what? Cos square x. And this is cos square x. If you want, you can write here. Otherwise, here you can write. Divide numerator denominator by cos square x. Yes. 2 get cancels, my friend. I equal to. This is pi into integral 0 to pi. Yes. This is sec square. Otherwise, I write 1 upon. This is a square plus. This I write it as what? B tan x whole square. B tan x whole square into, my friend, its derivative b into sec square x. Its derivative b into sec square x dx. See, if you take this as f, this is your f dash, but you have only sec square here. This b you must balance outside. This b is balanced outside. Yes, my friend. Tell once again which formula. You are very much aware. Integral 1 upon 1 plus fx whole square into f dash x dx is tan inverse fx. If instead of 1, if you have a here, a square, this is 1 by a into tan inverse fx upon a. Tan inverse fx upon a. Anyway, definite integral we are not bothering about c. Yes. 1 upon a square plus fx whole square into f dash x, which is, my friend, this is pi by b into 1 by a is there. Tan inverse fx is what? B tan x upon a. What are the limits? 0 to pi by 2. 0 to pi by 2. Pi by 2, and it is pi by 2, lower limit is here. Yes, my friend. It is pi upon AB, which is tan inverse. Tan 90 is infinity, minus 0. Tan 0 is 0. Right here, because tan pi by 2 is infinity and tan 0, putting x equal to 0, tan 0 is 0. Therefore, my friend, it is pi upon AB into, put x equal to pi by 2, tan 90 Tan 90 is infinite. Infinite into anything is what? Infinite. Minus lower limit. Put x equal to 0. Tan 0. Tan 0 is 0. 0 by anything is 0. But what is tan infinite, my friend? This equal to, this is I equal to. It is pi upon AB into tan inverse infinite is pi by 2 minus tan 0 is 0, which is pi square upon 2ab. Therefore, the integral 0 to pi, it is x dx upon a square cos square plus b square sin square is, my friends, it is pi square upon 2ab, pi square upon 2ab. This is the value of this definite integrals. Therefore, my friends, I told these are lengthy examples. Lengthy examples. Yes, my friends, copy it. Yes, friends, I will explain once again. See, through that, a definite integral 0 to pi x upon a square cos square plus b square sin square dx is pi square upon 2ab. Let I equal to this given integral. Replace your x by upper limit minus x, pi minus x. X is pi minus x. Wherever x is, there you write pi minus x. Already you know about this. Pi means no change. Cos is cos, sin is sin. As the angle is in the second quadrant, cos is negative because of the square. Again, it is positive. But sin is positive in the second quadrant. It is b square sin square. Right? Two integrals. Pi upon this dx minus x upon denominator dx. We have to use what for this? If you replace your x by pi minus x, this f of pi minus x becomes plus fx. Pi because of the square plus fx. So it is 2 times 0 to pi by 2 pi upon this. What is this, my friend? This we have taken this equal to what? I. This is I itself. Yes, my friend. Minus I taken to this side. I plus I, 2 pi. You have to divide. This pi is taken out. Otherwise, you can write if you wanted one more step here. This is, my friend, I plus I is 2i. That I, this minus I plus I is 2i equal to, this pi is taken out. It is integral 0 to pi. It is 1 upon a square cos square plus b square sin square dx. Now you divide both numerator denominator by cos square x. Both numerator denominator by cos square x. Yes, my friend. This is 2 pi. And I plus I is 2i. Therefore, 2i equal to this 2i equal to 2 pi. That 2 is cancelled. I equal to pi into 1 upon cos square is sec square, sin square upon cos square is tan square. Evaluation of this integral. See my friend, this is 1 upon a square plus b square tan square can be written as b tan x the whole square into what is the derivative of this? B into derivative of tan is sec square x, which is f dash. Therefore, it is 1 upon a square fx whole square into f dash. Because of this formula, it is 1 by a into tan inverse fx upon a. This is pi by b, 1 by a tan inverse fx, b tan x upon a, lower upper, put x equal to upper, tan 90 is infinite, tan 90 is infinite, anything is what it is, tan inverse infinite, minus, put x equal to 0, tan 0 is 0, this becomes tan inverse 0, this is pi by 2, this is 0, pi upon ab into pi upon 2, becomes pi square upon 2ab. Therefore, I is pi square upon 2ab means, get it as what, my friends? Therefore, tell this integral equal to pi square upon 2ab, pi square upon 2ab. Yes, this is the evaluation. These are lengthy, my friends. Yes, lengthy. Yes, my friend. Next is yes, my friends. Copy it. Copy. Yes, friends. Next example is to integral 0 to pi by 2 log sin x dx equal to it is pi by 2 into log 1 by 2. Yes, friend, let I equal to integral 0 to pi by 2 log sin x dx. Name this as 1. Yes, my friend, replace x, same theorem, x by pi by 2 minus x in 1. So it is same I equal to integral 0 to pi by 2. It is log sine x you are replacing by pi by 2 minus x dx. Pi by 2 means sine changes to cos. Sine changes to cos x. First quadrant sine is positive. This is dx. My friend, you call this as 2. Add 1 and 2. Add 1 and 2. I plus I. I plus I. Or you can write directly to I. Common integral. Integrand in the first log sin x plus integrand in the second equation log cos x. Log cos x dx. Yes, my friend. In case of log, plus is product. Plus is product. This is log. Product means it is sin x into cos x. Sin x into cos x dx. My friends, you know this property because log of uv product rule is log u plus log v. Log u plus log v. And apply from RHS to LHS. Log u plus log v is log uv. Sum is product. Product is sum. Sum is product of these two functions. Yes, my friends. You wanted here this equal to integral 0 to pi by 2 log. Divide and multiply 2 into. Divide 1 by 2 into 2 sin x cos x. Dx. But what is 2 sin x into cos x? 2 sin x cos x is sin 2x. Sin 2x. Yes, friends. Yes. Yes. 2i equal to integral 0 to pi by 2 log. It is a product. Yeah, it is 1 by 2 into sin 2x. Sin 2x dx. Yes. Now it is a product. This into this. What is product? Sum of the logs, right? This equal to integral 0 to pi by 2 log u plus log v. Log 1 by 2 plus log sin 2x dx. Write two separate integrals. It is integral 0 to pi by 2 log 1 by 2 dx plus second integral is this 0 to pi by 2 log sin 2x dx. Yes, you name this as I1 plus this is I2. This side is 2i. You pack it. Name this as equation 3. This is equation 3. Equation 3. Find one by one. First I1. I1. It is 0 to pi by 2. Log 1 by 2. Dx. That 1 by log 1 by 2 is out. Integral 1 dx. What is it? It is log 1 by 2. Integral of 1 is x, lower, upper, yes, equal to log 1 by 2. Put x equal to upper minus lower. Pi by 2 minus 0 is pi by 2 into log 1 by 2. Log 1 by 2, which is, my friends, I1 packet. This is I1. Next to go for I2. I2 is next, my friend. Next. Next. I2. Integral 0 to pi by 2 log sine 2x dx. Yes. Now you have, my friends, 2x. But in the given integral, my friends, it is x. We wanted that must be x. For that, put 2x equal to t. Put 2x equal to t. Differentiating 2 into dx equal to dt. And what is the value of dx? It is 1 by 2 into dt. Find the limits when x is 0. Limits when x is 0. What about your t? T is 0. Now when x is pi by 2, t is, it is 2 into pi by 2 means you have pi here. Substituting in I2, therefore I2 equal to integral 0 is 0, pi by 2 becomes pi, log sine t dt. That dt is what? 1 by 2 into dt. This is 1 by 2 into dt. This 1 by 2 comes out. Yes, my friend. Once again, what is your fx or ft? Your ft is log sine t. This. If you replace your t by f of pi minus t is log sine pi minus t is sine t itself. You are replacing your t by pi minus t. Again, sine pi minus t is sine t itself. Then, my friends, this is ft. This is ft. When it is ft, you are writing this is 2 times integral 0 to pi by 2 log sine t dt. That 1 by 2 is taken outside. Because of this, my friends, because of this, what is it? F of pi minus t is ft. Because of that reason, 2 times 0 to pi by 2. Yes, what is it? It is I itself. 0 to pi by 2 log sine x. Variable t changes to x dx, which is I itself. Therefore, my friend, I2 equal to I. I2 is I. Substitute these values in 1. Put these values where? In 3. In 3. Put these values in 3. These values. In third equation, 2i equal to c. What is I1? Pi by 2 log 1 by 2. Pi by 2 log 1 by 2. Minus here. This is plus I2. I2 is I. Bring this side 2I minus I. This is pi by 2 log 1 by 2. Yes, so I equal to either it is pi by 2 log 1 by 2 or yes my friend, if you take the reciprocal of this, if you take the reciprocal of this 2 by 1, if you take the reciprocal, the sign change minus 1. So this is minus pi by 2 log 2. Either it is pi by 2 into log 1 by 2. 1 by 2, if they take the reciprocal 2 by 1, power of this 1 by 2 changes to opposite minus p log minus pi by 2 into log 2. Therefore, my friends, your integral 0 to pi by 2 log sin x dx equal to either it is with a plus sign, it is pi by 2 log 1 by 2, or if you change this minus pi by 2 log 2. My friends, if you take 1 by 2, it is with a plus sign. If you take 2, it is with a minus sign. They may give either this or this. Pi by 2 log 1 by 2 or minus pi by 2 log 2. See, my friends, very, very lengthy example. This they will give under what? 6 marks directly instead of theorem and example. Directly they give only one example. Yes, 1 minute copy it. Another minute I will explain once again. Yes, friends, very lengthy. You wanted patience for this example. Yes, friends. Once again, very important example under 6 marks. Prove log sin x, definite integral 0 to pi by 2 log sin x dx is pi by 2 log 1 by 2 or minus pi by 2 log 2 or minus pi by 2 log 2 or minus pi by 2 log 2. Any one they give. Let the given integral replace sin pi by 2 minus x, sign changes to cos x. So your I becomes, my friend, log cos x. This is log sin x, it is log cos x. To evaluate log sin x, log cos x helps. To evaluate log cos x, you get log sin x. Again adding 1 and 2, from this the steps are clear, answer is also set. I plus I log sin x plus cos x. Yes, my friend. What is it? Sin x into cos x dx. Divide and multiply by 2. 2 sin x cos x, which is sin 2x. 1 by 2 into sin 2x. 1 by 2 into sin 2x. It is a product u v log u plus log v, my friend. Right? First integral I1 plus second integral I2. I1, I2. First to take first integral I1 0 to pi by 2 log 1 by 2 dx. Take outside, remains 1. 1. It is what? 0 to pi by, yes, 1. X. Lower, upper. Upper minus lower. Pi by 2 into log 1 by 2, which is I1. Next, my friend, I2. Integral 0 to pi by 2 log sine 2x. This 2x we want to convert single t. Let this equal to t. Differentiate this. Dx is half dt. When x is 0, t is 0. When x is pi by 2, t is pi. I2, this my friend, 0, lower, upper, log sine t, because 2x is t, half dt. Half is take outside. Now, what is it? Sine t. What is sine of pi by pi minus t? It is same sine t itself. So ft, f of 2a minus x is fx. That's sixth property. Because f of pi minus t log, what is it? Pi minus t. What is log? Sine pi minus t is what? Again sine t itself. It is log sine t. So it is ft. It is ft. If you wanted full, it is equal to, yes, my friend. See, we have taken ft is log sine t. You are replacing f by upper limit. This is upper limit pi minus t equal to sine, no, log sine pi minus t equal to log pi means no change, sine t, second quadrant sine is positive. Therefore, f of upper limit minus t, pi minus t is what? Plus ft. 2a minus x is plus fx. Then this integral 0 to pi can be written as 2 times 0 to half of the upper limit. 2a becomes a, pi becomes pi by 2 log sine t dt. 2 get cancels. Change from t to x, log sine x dx. This log sine x dx is, see, 0 to pi by 2 log sine x dx is I. This is I. Therefore, my friends here, this side is I2. I2 equal to I. I2 equal to I. Yes. Substitute these values of what? I1 and I2. I1 is pi by 2 log 1 by 2. I2 is I, where? In 3 LHS. I1, this. I2 is this. 2i minus I is this. 2i minus I is I. Pi by 2 log 1 by 2, or 1 by 2 if you take the reciprocal here, what is the power of 1 by 2? Power of 1 by 2 is 1. That sign changes, it becomes minus 1. Property of logarithm p comes outside, minus pi by t log 2. Therefore, I equal to what is your I? Log sin x dx is either pi by 2 log 1 by 2 or minus pi by 2 log. This is, my friends, answer for this integral. Yes, my friends. Very lengthy. Have a patience even while preparing this example. Yes, my friends. This much is enough today. Enjoy, especially this last example. Prepare nicely. This comes under 6 marks. 6 marks. Yes, my friends. Yes. Thank you very much. Namaste, namaskara, namaste.